Imagine you're asked to solve this equation. X squared plus 1 equals 0. We can also write this as x squared equals minus 1 if we subtract 1 from both sides of the equation. Pretty quickly, you'll notice there's no solution among the regular numbers. After all, no real number squared ever gives a negative result. But mathematicians don't like giving up. So they invented a brand new number, I, defined by just one simple rule. I squared equals minus 1. So I is equal to the square root of minus 1. This special number is called the imaginary unit, and it's the reason we have what are known as complex numbers. Before this, we couldn't solve this equation, but now we can see that x is equal to I or minus I, because if we square both solutions, we get minus 1. With the imaginary unit, we can create complex numbers. A complex number looks like this, a plus bi. It's important to note that a and b are ordinary real numbers. Some examples are 2 plus 3i, or minus 4 minus pi I. Let's see how we can find the solutions of x squared minus 4x plus 13 equals 0. We can do this by using the quadratic formula. So a is 1, b is minus 4, and c is 13. If we fill in those variables, we get a negative number underneath the square root. We get the square root of minus 36. But this is no problem because we can rewrite this as the square root of 36 and I squared. If we simplify this, we get 6i. And if we calculate the whole formula, we get 2 plus or minus 3i. So this is how we can calculate every solution of an equation. You can picture complex numbers as a point on a plane. A would be along the horizontal axis, and B along the vertical axis. We actually call the A part of a complex number the real part, and the B part the imaginary part. For example, the number 3 plus 4i would be plotted at the point 3, 4. So, in a way, complex numbers give us a whole new dimension. That's useful because it lets us derive the trigonometric equation as well. Instead of just describing a complex number by its coordinates, we can describe it by its length and angle. By the length, we mean the distance from the point in the plane to the origin. By the angle, we mean the angle that the line through the point and the origin makes with the x-axis. So the form is the modulus multiplied by cosine of the argument plus I times sine of the argument. The length is called the modulus, given by the square root of a squared plus b squared. The angle is called the argument. We can find it by the arctangents of b over a. Take our example 3 plus 4i. Its modulus is 5, and its angle is about 53 degrees. So we can write 3 plus 4i is equals to 5 times the cosine of 53 degrees plus I times the sine of 53 degrees. Now here's the really beautiful part. This form makes calculations with complex numbers far simpler. When you multiply two complex numbers, you just add their angles together and multiply both moduli with each other. This is an example. Feel free to pause the video if you want to give it a try yourself. The same method applies when dividing two complex numbers. Divide their moduli and subtract their arguments. Here is an example of that. And if you want to switch from the trigonometric form to the Cartesian form, you simply work out the cosine and sine. Here is another example of that. I hope you get the hang of it now. If this video helped you, feel free to leave a like or comment what you want to see next. I enjoy making these videos for you. See you in the next one.